Hello guys, welcome to Ramta Solutions. Welcome to a lesson on Coulomb's law. So in this video, we are going to follow the scope where the first part will be revising what you know about electrostatics from grade 10 and the introduction to Coulomb's law. And the second part, we will be looking at Coulomb's law and then look at the mathematical relationship. In fact, look at the mathematical relationship of the law and some examples, maybe one or two. Okay, so this is the scope that we are going to follow. Okay, all right. So without any waste of time, let's get into it. So in our first part, we're talking a revision and introduction, or maybe, and introduction. So you do remember in your grade 10, you looked at electrostatics. By now you know that an electric charge or charge is symbolized by letter Q, and it is the unit Coulomb, right? You know it has the unit Coulomb with symbol C, right? It is the letter Coulomb with symbol C. So these are the things that you know from grade 10. Again, from grade 10, you have also noted that like charges attract. Like charges repel, right? You know that like charges repel, and you also know that unlike charges attract, right? You also know that unlike charges attract each other, right? You also know that unlike charges attract each other and like charges repel, right? This is what you know about them. So maybe let me quickly draw something. Let's say this is a positive charge and this is a negative charge. Oh, another positive, and here let me try a positive and a negative, right? So these ones, they would basically repel each other, but these ones, they will basically attract each other, right? They will basically attract each other. So there'll be a strong attraction between these two, or there will be an attraction between these two, because one is positive and the other is negative, right? So you have also noticed, or rather you also learned in grade 10, that when charges are brought together, or when charges are brought into contact, right, when they are brought into contact, you know that the charges will be divided equally between the two, right? When they are brought into contact, you know that their charges will be separated. So basically, the new charge will be charge 1 plus charge 2 all over 2. Now here you are considering the nature of the charge, whether it's positive or negative. If it's a positive charge, you will specify that it's positive by letting your value be positive, and if it's negative, you will show that it's a negative charge, and basically you will have a positive minus whatever, right? So this is what you were doing in grade 10. Okay, this is what you were doing in grade 10. Now what we need to look at right now in grade 11 is that, like I said, like charges attract each other, right? We know that unlike charges attract each other and like charges repel each other, right? Remember, we said unlike charges attract each other and like charges repel each other. Okay, so you also know that, okay, right now what we're looking at is this, that we are basically looking at what we call an electrostatic force, okay, or rather you call it electrostatic force, right? You call it electrostatic force. So this is a non-contact force, right? It's a non-contact force, you know it. But what is it? This is the force experienced by charges that are at rest. Okay, let me write it down. Force experienced by charges at rest. Okay, by charges at rest. Okay, so this is what we term the electrostatic force. Okay, now this electrostatic force, we have seen that one, it increases with when the charges increases. Okay, increases when charges increase. Okay, so basically it also means it decreases when charges decrease. Now it also increases when distance between the charges decreases. Okay, when distance between the charges increases. Okay, so this is how this electrostatic force is affected. Okay, this is how this electrostatic force is affected. So what you're going to learn now in this topic, you're going to learn exactly how much is the increase in the charges affecting the increase in the forces, and vice versa, or alternatively, how much is the decrease in the distance between the charges affecting the force. Okay, you're going to learn about that. Okay, you're going to learn about that, so stay tuned. Okay, stay tuned. Now this is the introduction that we need. Now let us then head to Coulomb's law. Now for Coulomb's law, by the way, this is named after Charles Auguste de Coulomb, so I'm not gonna be writing that. It's not that important as yet, but of course we have to give him credit. Okay, this was named after Charles Auguste de Coulomb. So he's the one who studied electrostatic force. So I will say Coulomb observed. Okay, give him credit. Coulomb observed what he did. He observed that the magnitude of the electrostatic force in basically increases with the increase of the charges involved, and also increases when the square of the distance between the charges is decreased. Okay, so our beloved Master Coulomb, what he saw was that, okay, basically the magnitude of the electrostatic force between 2-point charges is inversely proportional to the square of the distance between the two charges. And not just that, and also observe that it is proportional to the product of the charges. So let's write that down. So he observed that the magnitude, he observed that the magnitude of the electrostatic force, let me write that, okay, of the electrostatic force, maybe I should add this, of the electrostatic force between 2-point charges, okay, between 2-point charges is 1, inversely proportional to the square of the distance to the square of the distance between the 2 point charges. That's the first condition, or the first observation. Inversely proportional to the square of the distance, between the 2 point charges. Alright, to the square of the distance between the 2 point charges. Number 2, he also observed, I want you to know this, inversely proportional to square of the distance. Now, number 2, he also observed that the magnitude of the electrostatic force between 2 point charges is directly proportional, right? Is directly proportional to the product of the charges. Directly proportional to the product of the charges. Okay, to the product of the charges. Alright, to the product of the 2 charges. So remember, we're saying that Mr. Coulomb observed that the magnitude of the electrostatic force between 2 point charges is directly proportional to the square of the distance between the 2 charges. So basically, he had said this is inversely proportional to, let me write this as R, okay? So it is inversely proportional to the square of the distance between the 2 point charges. So as you can see, F is indirectly proportional or inversely proportional to square of the distance between them. Now, he also said this force is also directly proportional, let me underline here, directly proportional to product of the charges. So that means you have 2 charges, maybe let's call them charge 1 and then charge 2, okay? The product of the 2 charges, okay? This is what he had said, okay? This is what he had observed rather. But remember, the title is Coulomb's law. So what is Coulomb's law saying? So Coulomb's law says, note, Coulomb's law says the magnitude of the electrostatic force between 2 point charges is directly proportional to the square of the distance. Is directly proportional to the magnitude of the charges and inversely proportional to the square of the distance between them. I'm going to write that down. So it states magnitude, or the magnitude of the electrostatic force between 2 point charges, right, between 2 point charges. That's important. 2 point charges is directly proportional. All right, is directly proportional to the product. All right, is directly proportional to the product of the magnitude, of the charges, and inversely proportional to the square of the distance, between them. Alright, to the square of the distance between them. Okay? Now remember, most of your physics formulas that you're going to come across, most of the physics laws that you will come across, in fact, laws and definitions, they will somehow or directly be giving you the formulas used, okay? So remember, we're saying the magnitude of the electrostatic force, we call it F, is directly proportional. So to say directly proportional would mean it's, if it was a fraction, directly proportional. The quantities that are directly proportional will be the numerators. And it is also inversely proportional to the square of the distance between them. So whatever that we say is inversely proportional will be the denominator. However, there is a relationship, or there is something that connects all these quantities together, and that we call a constant. In this case, we're going to call it K. Okay, so this K is called the electrostatic constant. Okay, this K is the electrostatic constant, right? It's the electrostatic constant. It has the magnitude 9,0 times 10 to the 9 in Newton meter squared per Coulomb squared. By the way, you should know by now that the force F is the electrostatic force, right? So it's the electrostatic force. Okay, it's the electrostatic force, which is measured in newtons. Q is charge, right? It's charge measured in coulombs, and R is distance. Okay, R is distance measured in meters. Remember, guys, this C is a capital C. Okay, it's a capital C. Okay, so these are what these things mean. Okay, these are what these things mean. So check how far we've come now. Revision, done. Coulomb's law, done. Now we need to look at the mathematical relationship. Okay, now we need to look at the mathematical relationship. So now we are done. So this is the formula that you're going to use. Okay, this is the formula that you're going to use. Guys, remember that force is a vector quantity. So whenever you make your calculations, you must also state the direction. But because this is an it's a non-contact force, what you're going to do, you're going to mention whether the force is attractive or repulsive. Okay, so you have those two options. It's attractive force or repulsive force. Okay, all right. Now let's look at the mathematical relationship. Let's look at the mathematical relationship of Coulomb's law. Okay, mathematical relationship of Coulomb's law. Okay, of Coulomb's law. So what we had said was that Coulomb's law, the formula is F equals K Q1 Q2 or Q sub 1 Q sub 2 over R squared. Now, in addition, we have also said F is directly proportional to Q1 Q2, which is also inversely proportional to square of the distance between them, right? So now, let's see what happens when let's look at effect of Q on F, okay? So here, what are we looking at? We're looking at, basically we're saying if everything else is constant, in other words, if the square of the distance between the two charges is constant, what will you have? You can find this relationship by saying Q1, Q2, right? So what if you increase, now let's say you increase Q1, what will be your force? When you increase Q1, Q2, and maybe say double, okay? When you double Q1, so Q1 will be twice what it used to be, and obviously Q2 was constant. All right, so what does this mean? This means the new force is double what it used to be, right? So this means the new force is 2 times the old, right? So when you double the charge, the force is doubled. Now let's say you double both, okay? Double both charges. So let's say you double both charges. What happens? I want you to look at it now. When you double both charges, what you will have will be 2 times 2, which is 4. Therefore, the new force will be 4 times the old force, right? Now, let's say we now have, let's have Q1. Remember, it doesn't matter Q1 or Q2. What happens? And the other one is constant. But in this case, let's take Qy. We will say this is half times 1. What is this? This is half. So what does it mean? The new force will be half the old force. All right? In the same way, have both. When you have both, you will be having half times half. And what is that? This is 1/4. So the new force will basically be a quarter of the old force. So what are you seeing here? So what you're seeing here, look at it. When you increase the magnitude of the charges, force increases. Can you see that? We have increased, whether we increased 1 or 2. When you increase the magnitude of the charge, force increases. In the same way, when you decrease the charge, force decreases. Whether you decrease one or both, but when you decrease the charge, the force increases. So now this basically shows you the direct proportionality that we were talking about. Okay? So even if your exam question gives you one was halved and the other was reduced in 4 parts or in quartered, you can make this calculation to find your answer. And this is your typical multiple choice question. Okay? This is your typical multiple choice question. So now let's look at effect of distance on F. Okay, let's look at effect of distance on F. What is it? So remember, we had said F is indirectly proportional, right? We have said F is indirectly proportional to the square of the distance, right? So what we're saying here is that, okay, we basically are saying if we keep charges constant and only alter the distance between the charges, we will be having something like this. Okay, we will be having something like this. So let's now try to see what's going to happen if we, maybe I should go to the next page. Let me go to the next page. Okay, so I was saying we're looking at effect of R on, meaning effect of this distance between the charges on the electrostatic force. So we said this force is indirectly proportional to the square of the distance between the charges, right? So what happens when we increase R? Let's say double it. Okay, let's say we double it. When we double R, let's try it. F equals 1/, double would mean twice what it used to be. So this would be 1/4. Now, this means the new force, as you can see, something that you guys must see, it's inversely proportional, right? It's inversely proportional. You have increased the distance, right? You have doubled the distance. What does it mean? It means the force is quartered. I want to use the word quartered. I don't know if it's right, but yeah, I will use the word quartered. Right, so you have reduced it by a quarter. Can you see that? Now, let's try, if you triple it, let's say triple r. If you triple r, triple the distance, what do you have? You have 1 over 3 squared, which is 1 over 9. What happened? This means the new force will be reduced by 1/9. Right? Can you see that? Okay. Now, let's now try to halve the distance. Okay? Let's try to halve the distance. Okay? Let's try to halve the distance, meaning half r. When we have r, what happens? Let's see. F equals 1 over a half. Right? What is this? This is 1 into 1 over 4. So this is basically 4. So what does it mean? The new force is 4 times the old. In the same way, if we say, let's say now decrease it by a factor of 1 over 3, okay? Decrease it by a factor of 1 over 3. What will happen? F will be 1 into 1 over 3, right? And this is 1 over 9, which is 9. So what will be the new force? So the new force will be 9 times the old. Can you guys now see that? So now you can get this thing in your multiple choice questions. So in your multiple choice questions, when they ask you these things, you can do these calculations, and trust me, you are good to go and you will get all your full marks. Okay? And you will get all your full marks. Okay, guys. So the example, because so far the video is too long, we're going to do examples in the next video. Okay, we're going to do examples in the next video. I hope you now understand this and you won't have struggles with this topic. So I will see you in the next video when we are looking at examples. So without any waste of time, let me say I'll see you next time, and bye.